Welcome to the fifth video of this 5-part video series on Surds. So you know that means that this is the last video, and I hope that this series has been helpful. We're going to talk in this video about rationalizing the denominator. Now, mathematicians can sometimes be a little bit strange and weird and have a certain set of rules that a lot of people don't really understand why they exist, and this is one of those cases. So we have 1 over root 3, and a mathematical norm here or convention is that you just don't write fractions with an irrational denominator. So that 1 over root 3, and there's a really good reason for it, and it helps in terms of our classification, in terms of comparisons, and it also helps in terms of fraction arithmetic later on. So we make it a standard that we just don't have a irrational denominator, which means that you may be asked to rationalize a denominator, but you may also just get an answer with an irrational denominator, and we would expect you to rationalize that just as part of the question. So make sure that you do that. Let me show you how to rationalize this denominator. We have a root 3 in the denominator, and we really don't want to have that root 3 there. But we can't do a lot to change the fraction. We don't want to change the number. We don't want to change the value of it. So what we're going to do instead is we're going to multiply the denominator by root 3, because we know that root 3 times root 3 gives us 3, which is now a rational number. But we don't want to change the fraction. So we're going to multiply by root 3 in the denominator and also root 3 in the numerator, because root 3 divided by root 3 is equal to 1. And multiplying anything by 1 doesn't change the fraction. So this should be all good, and we can test it once we've finished. So if I multiply the numerators, I get root 3, and I multiply the denominators, I get 3, because root 3 times root 3 is 3. So I have succeeded in rationalizing the denominator, and if you check it on your calculator, you'll find that it has the same value. 1 over root 3 is equal to root 3 over 3. In fact, working on your calculator, you'll find that your calculator often will give you this answer first. You might have found in the past that when you're checking your answers seemed wrong. That's because the calculator automatically rationalizes the denominator. Let's have a look at example B. 2 over root 7. In this case, we want to multiply the bottom by root 7, so we multiply the top by root 7. And this comes out as 2 root 7 over 7. Now, of course, we always do a check to see if we can simplify the fraction or simplify the surd, and in this case we can't. So that's our final answer. And let's have a look at question C. 1 plus root 3 over 2 root 5. Now in this case, I want to multiply the denominator by root 5. You might find examples, and you might find people that teach that you multiply by 2 root 5. It will achieve the same purpose. Either way, I'm going to go with just multiplying by the actual surd. I'm going to multiply this one by root 5 as well, so I keep that 1 that I'm multiplying by, root 5 over root 5 equals 1. And now I do that multiplication. So I get root 5 times by the top, which has 2 terms this time, so I have to be careful, over 2 times root 5 squared, which is just 2 times 5. And I distribute the top, giving me root 5 plus root 15 over 10. And that is fully simplified. Root 5 and root 15 are in their lowest terms, and there's not much more I can do with that. And in fact, in some cases, you might even leave the numerator in this form, in a factorized form. But for now, we don't have to worry too much. Now I'm going to show you, I'm going to put a little line here because this is the last thing I'll show you. It's a little bit above and beyond. It is rationalizing a denominator that has multiple terms. And I'm going to teach you the idea of a conjugate in this case to show you why this works. So let's have a look at a couple of examples here that look more like this. 1 over 1 plus root 3. Now this is beyond the syllabus. So you can play around with this if you want to, but you're also welcome to stop the video now because this won't be in one of our Year 10 exams. Feel free to stop the video now if you'd like. But in the meantime, rationalizing this type of denominator. The key here is this, the difference of two squares. A plus b times a minus b is equal to a squared minus b squared. So if either of a or b is an irrational number or a surd, when you square it, it won't be a surd anymore. So this will be a rational number. So what we're actually going to do is we're going to multiply by, in the denominator, 1 minus root 3. And we're going to use this rule, because when we do that multiplication, it will come out as 1 squared minus root 3 squared. Now hopefully you remember that we have to multiply by the same in the top as we multiplied by on the bottom, because that will mean that it's equivalent to 1. And so on the top we'll have 1 minus root 3. And that remains on top, we can't simplify that. But in the denominator we'll have 1 minus root 3 squared, which is 3. And that will give us 1 minus root 3 over negative 2. Now that's the right answer. We could pretty much stop there. But there is one other nice little thing that we should do. Because as well as not having irrational denominators, we really don't want to have negative denominators either. So here's a little trick again. Let's multiply by negative 1 over negative 1, which just equals 1. The bottom just becomes 2, the denominator. The numerator, the negative root 3 becomes positive, and the positive 1 becomes negative. So we can just swap those terms around, swap whether they're negative or positive, and the denominator becomes positive. And that's our final answer. So 1 over 1 plus root 3 is the same as root 3 minus 1 over 2, but now it has a rational denominator. It's rationalised. And a last example, a little bit trickier. 2 plus root 3 over 2 minus root 3. And I'm going to multiply this by 2 plus root 3 over 2 plus root 3. I'll just put that in brackets, so I haven't been doing that. I don't know why I did that, but I did. And this, of course, is 2 plus root 3 squared. And using our difference of two squares up here, the denominator becomes 2 squared minus root 3 squared. And the top, the numerator, if you remember back to our expansions in video 4, binomial products, then you will recall that that just becomes 2 squared minus 2 times the first term, which is 2, times the second term, which is root 3. Sorry, not minus, plus that. And then plus root 3 squared. All over 2 squared is 4, root 3 squared is 3. And so this is now equal to 4, 2 squared is 4, plus 4 root 3 plus 3 all over 1. 4 minus 3 is 1. And that, of course, is equal to 4 plus 3 is 7, plus 4 root 3. And convince yourself that this is equal to that. It's true. Trust me. Well, that's it. That is rationalising denominator, and in this instance, that is the end of my third video series. I hope it's been helpful. Obviously, you're more than welcome to make contact if you need any further clarification.